Quick show of hands, how many first years do we have here? How many second years? Third? Fourth? Fifth and beyond? Okay, all right, so how many people have heard of a carbon nanotube? Show of hands. So relatively large number of people. How many people have heard of MEMS, that acronym? Less people. How many people have a laptop? Everybody. So what I'm going to talk about in this new track is basically micro-nano engineering, and there are a lot of faculty that are involved in this research area. It's multidisciplinary by nature, and there's a lot of terminology. Some of it's going to be familiar to you, some of it's going to be new, but I want to kind of walk you through a little bit of the history of nanotechnology. Maybe some of you have heard of Richard Feynman, very inspirational thought leader in nanotechnology that really was inspiring people to take a look at things at the bottom. Basically, one of the famous situations that he put out there was that imagine if we could take all the books in the world and we could scribe them on the head of a pen. And that's really what the chase for nano and micro engineering has been, is to try to manipulate things at these small scales and apply engineering. So when we think about that as engineers, Georgia Tech engineers, we just can't be fascinated with the science. We have to do something with it. So we have to move from nanoscience, microscience to technology. And this guy here, maybe few of you have heard of Richard Smalley, probably less than Feynman, was someone that was really trying to motivate people to take the nanoscience and address grand challenges like energy, health, communications, water, all these things by making new phenomena useful through technology. Probably none of you have heard of this guy. There are many people that can be considered pioneers in nanoengineering. This is just one that I chose because he's someone I'm familiar with in the heat transfer area. But taking the next step from technologies and actually making them into products, and understanding when you look at technologies from the small scale, whether you're making them or you're studying them, you understand their system properties, how does that fit together into making a useful application? And this is just one example of using carbon nanotubes for cooling electronics by making contact between a chip and a heat sink. So I wanted to show you here, and these slides will be available, of course. These are some people, just a few of the people at Georgia Tech that are nano engineers. So if you want to get a feel for the type of things that go on with micro nano engineering, you can look at some of these folks in their lab. You also see that our president is on that list as well. So some examples. Maybe some of you have, maybe some of you haven't seen things that are starting to come to life from nano. So this is someone that I'm familiar with who's making carbon nanotubes, these single molecular structures, into sheets. And this is really what nanoengineering is about. Understanding systems at small scales, being able to manipulate things, and then eventually assembling them at the level of human interface, which is something like a sheet that has high conductivity, high strength, that you can put into a useful form. Right, so if you look at this under the microscope, the electron microscope, you see billions of aligned carbon nanotubes making up this structure. So engineering, I wanted to really try to define this, just because even though most of you are familiar with these concepts of nano and micro scale, just hearing them, I wanted to be clear about what we mean when we talk about engineering and doing useful things, and then moving from the micro and nano engineering up. And it's about making this phenomena useful. And it's important to understand where you have to start with this, because the courses that we've designed as a faculty for you are designed to help build your skill set in these areas that really define the micro and nano. So the chemistry and the physics, these are the things that you've had as prereqs, but need a little bit more in-depth learning of in order to be a nano engineer. There's a lot of things that have to do with surfaces and fundamental physical phenomena that feed into that. So if you look at this, this is the course list that we put together so far. There's one required course. It's a design course that really looks at systems from an energy perspective. A lot of the things that are micro and nano tend to have something to do with transport, which is related to energy. There's a new course, 2 new courses that have been developed, One, fabrication and properties of nanoscale devices, been taught a few times. There's one that's being taught this semester by me that's Nanoengineering Energy Technologies. And there are a few more courses that you have to choose from. And it's kind of divided up. If you look at the chemistry and the physics courses, I'll talk more about this in detail at the extended meeting. There's some prereqs that you have to look at, but it's going to give you a more rigorous treatment of the nanoscale things. So that concludes that.